Welcome students to lecture number 10 on the MOOCs course on fuzzy sets, arithmetic and logic. If you remember, we are working on fuzzy arithmetic. In particular, we have discussed addition on triangular fuzzy numbers. We have shown that can be done in two ways. The basic procedure for such arithmetic operations is through alpha cuts. If O is the arithmetic operation, to be performed on two fuzzy numbers A and B, then alpha cut of A of B is computed through the alpha cuts of A and B. That is, if alpha cut of A is equal to x alpha comma y alpha and alpha cut of B is equal to u alpha comma v alpha, you have to understand that these are closed intervals on the real line, then alpha cut of A O B is computed through the interval operation on x alpha comma y alpha and the interval u alpha comma v alpha. Therefore, when we add two fuzzy numbers, then we can write alpha cut of A plus B is equal to x alpha comma y alpha plus u alpha comma v alpha is equal to x alpha plus u alpha comma y alpha plus v alpha. This we have already seen in the last class, and then what we do, then from the alpha cut of A plus B, we compute the membership functions. In particular, we have worked out on an example with two triangular fuzzy numbers. Why generally we use TFNs? The advantage of TFN is that the Lx and Rx, that is the membership functions on the left side and membership function on the right side of the fuzzy number, are linear, and therefore, it is easy to calculate membership functions from the start point and the end point of the line segment. Also, it is easy to compute the membership function from the alpha cuts. Example, suppose we have a fuzzy number like this. Between A to B it is linear and between B to C it is linear, then Lx is equal to x minus a upon b minus a for x belonging to a comma b. That you get from simple geometry and the similarity of triangles between this and this. In a similar way, R x is going to be c minus x upon c minus b for x belonging to b comma c. As you can see that putting the value of x is equal to b, we get 1, but putting the value of x is equal to c, we get 0. Therefore, when in a TFN we just mention the 3 points A, B, C, then we know the entire fuzzy number. Please note that when I am using a TFN, I am not putting any comma and there are 3 numbers A, B, C, which is different from A comma B, which is basically a closed interval. So, you have to remember that A, B, C is a TFN and A, B, C, D is a trapezoidal fuzzy number, which will have a shape very similar to a triangular fuzzy number. Only thing is that between B to C it will have a membership value 1. We have further shown that if A, B, C and M, N, P are two fuzzy numbers, say A and B, then A plus B is actually the TFN A plus M, B plus N, C plus P. You can prove it in general, but in the last class I have given you an example and I have shown by using the interval operations on the alpha cuts of A and B, we have actually got this to be the answer. I like you to check that A minus B is equal to A minus P, B minus N and C minus M. How do I get it? Because the minimum value when I am subtracting M and P from A, B, C, the minimum value will be when I take the smallest value here and subtract from it the largest value here. That is why I get A minus P to be the smallest point in A minus B. In a similar way, it is going to be C minus M for the maximum point. Therefore, the support of A minus B is going to be the interval A minus P to C minus M, and since we know the 3 points of the TFN, we know how to find the membership functions for all x belonging to this interval, and just now I have shown how to calculate that. In a similar way, we can add and subtract two trapezoidal fuzzy numbers. Example or illustration: if A1, A2, A3, A4, so let me call it A, and B1, B2, B3, B4 is equal to B are two trapezoidal fuzzy numbers, then A plus B is also a trapezoidal fuzzy number, which is A1 plus B1, A2 plus B2, A3 plus B3 and A4 plus B4. And A minus B is equal to A1 minus B4, A2 minus B3, A3 minus B2 and A4 minus B1. I am not working out this because this is simple, because the membership functions are linear. I want you to verify this by taking two arbitrary trapezoidal fuzzy numbers and actually working out on them using the interval operations. Let me now change my focus to fuzzy multiplication. We want to multiply two fuzzy numbers A and B given their alpha cuts x alpha comma y alpha and u alpha comma v alpha respectively. Then alpha cut of A multiplied with B is given by the following. Alpha cut of A star B is equal to minimum of x alpha dot u alpha, x alpha, this is the product v alpha, y alpha multiplied by u alpha and y alpha multiplied with v alpha. So, depending upon the sign of x, u, v and y, we may get different expressions to be the minimum. So, in each individual case, we will have to compute these four and we have to see which one of them is minimum. So, that is going to give you the lower bound of the alpha cut and the upper bound is going to be very similar expression, but in this case we are going to consider the maximum of x alpha multiplied by u alpha, x alpha multiplied by v alpha, y alpha multiplied by u alpha and y alpha multiplied by v alpha. So, this interval that we get is going to give us the alpha cut. But the difference with addition or subtraction is that it is not that one function will remain the minimum for all alpha between 0 to 1. So, for different values of alpha belonging to 0, 1, we need to check the corresponding alpha cuts. Now, I illustrate this using an example. Consider two TFNs A is equal to -1, 1, 3 and B is equal to 1, 3, 5. Therefore, mu A of x is equal to 0 if x less than -1 or x greater than 3. It is x plus 1 by 2 when -1 less than equal to x less than equal to 1. This is 3 minus x by 2 when 1 less than x less than equal to 3. This we can obtain very easily by considering these three values a, b, c and then applying the formulae I have given just some time back. Similarly, mu b x is equal to 0 if x less than 1 or x greater than 5. It is x minus 1 by 2 if 1 less than equal to x less than 3 and it is 5 minus x by 2 if x if 3 less than equal to x less than equal to 5 and as we know it is 0 above 5. Therefore, alpha cut of A is equal to two alpha minus 1 comma 3 minus 2 alpha. How do I get it? So, our A is minus 1, 1, 3. So, this is the shape of A. So, for any alpha, I am looking at x alpha and y alpha. So, we can use the geometry again or the similarity of these triangles again to compute alpha cut of A. In a similar way, alpha cut of B is equal to 2 alpha plus 1 comma 5 minus 2 alpha. Therefore, alpha cut of A star B is the interval minimum of two alpha minus 1 star 2 alpha plus 1 comma 3 minus 2 alpha multiplied by 2 alpha plus 1 comma 2 alpha minus 1 into 5 minus 2 alpha and 3 minus 2 alpha multiplied by 5 minus 2 alpha. And the upper limit is going to be maximum of the same 4 quantities. So, let us first calculate the values. Therefore, alpha cut of A star B is equal to minimum of 4 alpha square minus 1 minus 4 alpha square plus 6 alpha minus 2 alpha plus 3 10 alpha minus 5 minus 4 alpha square plus 2 alpha and 15 minus 10 alpha minus 6 alpha plus 4 alpha square, and similarly the upper bound is maximum of these numbers, which when we simplify we get alpha cut of A star B is equal to minimum of 4 alpha square minus 1 minus 4 alpha square plus 4 alpha plus 3 10 alpha minus 4 alpha square plus 12 alpha minus 5 and 4 alpha square minus 16 alpha plus 15, and the upper bound is maximum of these 4 quantities, namely 4 alpha square minus 1 minus 4 alpha square plus 4 alpha plus 3 minus 4 alpha square plus 12 alpha minus 5 and plus 4 alpha square minus 16 alpha plus 15. Fairly complicated terms, and therefore, we need to check for different values of alpha which one of them is going to be minimum and which one of these is going to be maximum. So, let us try to understand the shapes of these 4 curves. For alpha square minus 1, its value is minus 1 at alpha is equal to 0. Suppose we put alpha is equal to half. So, it is 0 at alpha is equal to half and 3 at alpha is equal to 1, and its derivative is 8 alpha. Therefore, it is increasing in 0 to 1 values for alpha. The next equation is minus 4 alpha square plus 4 alpha plus 3. At alpha is equal to 0, it is 3. At alpha is equal to half, it is 4. And at alpha is equal to 1, it is 3 again. And its derivative is minus 8 alpha plus 4. Therefore, increasing in 0 to half and decreasing in half to 1. From the sign of the derivative, we can calculate in 0 to half, it is going to be positive, therefore, it is increasing. From half to 1, this value is negative, therefore, it is decreasing. The third equation is minus 4 alpha square plus 12 alpha minus 5. Its value is minus 5 at alpha is equal to 0. At alpha is equal to half, its value is 0 at alpha is equal to half, because this is 1 by 4. So, minus 1, it is 6, it is minus 5, and at alpha is equal to 1, its value is going to be minus 4 plus 12 minus 5 is equal to 3. Derivative minus 8 alpha plus 12. Therefore, it is increasing in 0 to 1 values for alpha, because throughout it is remaining positive. And the fourth function is four alpha square minus 16 alpha plus 15. Its value is at alpha is equal to 0, it is 15. At alpha is equal to half, it is going to be 8, and at alpha is equal to 1, it is going to be 3, and derivative is equal to 8 alpha minus 16. Therefore, it is decreasing for alpha belonging to 0, 1. Now that we have seen the nature of the four curves, let us draw the curves for the above four functions. Note that A is equal to minus 1, 1, 3, and B is equal to 1, 3, 5. Therefore, the minimum value that can happen is minus 5 and the maximum value that can happen is 15. Therefore, we have to plot the curves for x belonging to minus 5 to 15. So, let us call them minus 5, minus 3, minus 1 and then 0 and then 1, 2, say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So, let us consider 4 alpha square minus 1 at alpha is equal to 0, it is minus 1, at alpha is equal to half, it is 0, and at alpha is equal to 1, it is 3. So, the shape of the curve is, since it is increasing, we can get this curve. So, this is the curve 4 alpha square minus 1. The second one is minus 4 alpha square plus 4 alpha plus 3. At alpha is equal to 0, it is 3. At alpha is equal to half, it is 4, and at alpha is equal to 1, it is 3. Therefore, the shape of the curve is going to be like this. This is the curve minus 4 alpha square plus 4 alpha plus 3. Let us now draw minus 4 alpha square plus 12 alpha minus 5. It is at alpha is equal to 0, it is minus 5. At alpha is equal to half, it is 0, and at alpha is equal to 1, it is 3. Therefore, this curve is going to look something like this. So, this one is minus 4 alpha square plus 12 alpha minus 5, and then the last curve is 4 alpha square minus 16 alpha plus 15. At alpha is equal to 0, it is 15. At alpha is equal to half, it is 8, and at alpha is equal to 1, it is 3. Therefore, this curve will look like something like so. This is the curve for 4 alpha square minus 16 alpha plus 15. Therefore, what is going to be the minimum? We can see that between 0 to half, the minimum is given by this function minus 4 alpha square plus 12 alpha minus 5. Between half to 1, the minimum is given by 4 alpha square minus 1, but the maximum for the entire range of 3 to 15 is given by 4 alpha square minus 16 alpha plus 15. Therefore, alpha cutoff A star B is equal to minus 4 alpha square plus 12 alpha minus 5 to 4 alpha square minus 16 alpha plus 15 for 0 less than equal to alpha less than equal to half, and it is 4 alpha square minus 1 to 4 alpha square minus 16 alpha plus 4 alpha square minus 16 alpha plus 15 for half less than alpha less than equal to 1. So, this gives us the alpha cut for A star B. Now, we need to compute the membership functions. How to do that? We do in the following way. For x belonging to minus 5 comma 0, the equation is minus 4 alpha square plus 12 alpha minus 5, or 4 alpha square minus 12 alpha plus 5 plus x is equal to 0. Therefore, by solving for alpha, alpha is equal to minus b plus minus root over b square minus 4 into 4 into 5 plus x upon 8 is equal to 12 plus minus 12 plus minus 144 minus 80 minus 16x by 8 is equal to 12 plus minus root over 64 minus 16x by 8 is equal to 3 plus minus root over 4 minus x by 2. Since alpha belongs to 0 1, it is, since if this is going to be positive, then 3 plus this quantity is going to be above 1. Therefore, since 0 less than equal to alpha less than equal to 1, it cannot be 3 plus root 4 minus x upon 2 as x belongs to minus 5 comma 0, because in that case it is going to be above 1. Therefore, alpha is equal to 3 minus root over 4 minus x by 2, or mu a star b of x is equal to 3 minus root over 4 minus x by 2. So, this gives us the membership value if x belongs to minus 5 comma 0. For x belonging to 0 to 3, we have the equation x is equal to 4 alpha square minus 1, or alpha is equal to x plus 1 root over by 2 plus minus, since it cannot be minus, therefore, for x belonging to 0 to 3, mu a of x, which we denote by alpha, is equal to root over x plus 1 by 2. And finally, for x belonging to 3 comma 15, we have four alpha square minus 16 alpha plus 15 is equal to x, or 4 alpha square minus 16 alpha plus 15 minus x is equal to 0. Therefore, alpha is equal to 16 plus minus root over 256 minus 4 into 15 minus x divided by 8, which when we simplify we get 2 plus minus root over 1 plus x by 2. We cannot take plus, because in that case it is going to be above 1. Therefore, we will look at 2 minus root over 1 plus x, which when we simplify will give us alpha is equal to 2 minus root over 1 plus x by 2. Therefore, mu a of x is equal to 2 minus root over 1 plus x by 2 for x belonging to 3 comma 15. In this way, we get the membership functions for x for the entire support of -5 to 15. Thus, we get mu a star b of x is equal to 0 if x less than -5 or x greater than 15, 3 minus root over 4 minus x by 2 for x belonging to -5, 0, root over x plus 1 by 2 for x belonging to 0, 3 and 2 minus root over 1 plus x by 2 for x belonging to 3, 15. In a similar way, we can find the mu a by b x, which is the fuzzy number a by b when b does not contain 0 in it, and compute the membership functions for different x belonging to the fuzzy number a by b. Okay, students, I stop here today. Thank you.